Hello everyone, so in this video let us talk about the first three problems from the latest Leetcode weekly contest 304. So let's start. The first problem is make array 0 by subtracting equal amounts. So the problem statement goes like this, that you're given a non-negative integer array nums. In one operation you will do the following things, that you have to choose a positive integer x such that x is less than or equal to the smallest non-zero element in nums, as well as subtract x from every positive element in nums. Okay, and you have to keep on doing this operation multiple times such that all the elements in nums should be equal to 0 after all of those operations. Like how many operations will you have to do, such that you have to minimize the number of operations. That's the overall problem. How you can do that? The problem, what you can see is that you are given some array and you have to choose x such that x is the smallest non-zero element. Now what you'll do here is that because you have to minimize the number of operations, you will choose the smallest element. Okay, x is equal to the smallest element, and you have to subtract x from all the elements. Now because the constraints are very small, you can do this in a very brute force way, whatever manner you can think of. But what you can directly see is that first sort the whole array out. If you sort the whole array out, I will be having the element that is the very smallest to the very largest. That is fine. And I will take the very smallest element and subtract that element from all the elements on the right side, because all the elements on the right side will be having more elements, like more positive elements, or will be larger than to the current element because it is sorted. And we'll keep on doing this operation until we have 0. So let's take an example so that it will become more clear to you. This is 15035. So 15035. Let's sort this whole array out. So we have now 0 1 3 5 5. Now what will happen is, let's say we'll do a for loop over this whole array, and whenever I see a 0 element, it doesn't matter to us, but when we find a non-zero element, let's say this, that is 1, what I'll do is I'll subtract, because this is one of the smallest element in the array currently. Okay, because it is sorted, obviously all the elements on the right as well will be greater than or equal to this element, but this element will be smallest because it is sorted. So what I'll do is I will, let's say, take an array, or let's say a variable, that is how many number of operations you have to do. Let's say it is 0. Now whenever I see a non-zero element, I will subtract this element from all the elements to the right of it. So we will do a for loop subtracting all the elements on the right of it with this number. So it will become 0. This will become, this is already 0. This will become 2. This will become 4. This will become 4. And because we have done one operation of subtracting all the elements, we will increment this one. Now we'll move to the next element. Now obviously because it is sorted, the next element, whatever it is, will be the next smallest element because it is in sorted order. So I'll just take this element, subtract everything. So total number of operations we have done will also increment by 1. It will become now 2 operations. It will become 0 0 2. Then again take the next element, it is 2, subtract all the elements to the right of it by this. Total operation will become 3. So it will become 0 0. Now when I come to this, because it is already 0, or let's say the array is like this, it is 0 1 1 3 5 5. When I go to this point, I see that it is 1. I subtract all the elements to the right of it by 1. It becomes 0 0 3 5 5, or let's say 2 4 4. But I already see that when I come to this element, it is already 0. But I will only take out elements that are non-zero. So whenever I do the for loop, whenever I find out the positive number, okay, then only I take that number, increment my total number of operations that I've done, and separate every element on the right of it by that number, and then keep on doing this operation. So this is O of n square operation. Why? Because for every element we are doing, and we are going over it, and for every element we are subtracting all elements on the right of it by this particular number. So O of n nested for loop of n square. That's the logic for this first problem. Coming down to the code, total is the total number of operations we'll do, n is total size, sort this whole array out, move from left to right over this using this for loop. If the current number is greater than 0, because then only we'll do this operation. Increment the total, because now it's greater than 0, we'll take this element, increment the total, that now we will subtracting all elements on the right of it by this number. Take out this number, iterate over from I to all the elements to the right, and if it is greater than 0, which is if it is positive, subtract all the elements by this current value. And then we'll keep on doing this until we have iterate over the whole array. That's answer. That's the first problem. Moving on to the second problem. The second problem is maximum number of groups entering a competition. So this problem seems very large, and you will understand that some of the information is irrelevant here. They have just put it down for making the problem confusing, but it is very simple. So the problem statement goes like this, that you are given a positive integer array grade. So you are given some grade array, and you have to represent these grade students to a competition, let's say. So what you will do is that you have to order out these people in some different groups, but whenever you find a groups, you have to meet some certain conditions. The conditions are the sum of the grades of the student of the ith group should be less than the sum of the students of the I+1 group. So if you are like, let's say, forming 5 groups, 1, 2, 3, 4, 5, thus it should be in an increasing order. The first group will be having the least total sum of all the grades of the students inside that. The next group will be having more sum, more sum, and so on. It is in an increasing order. Next thing is the total sum of students in the ith group is less than a total of students in the I+1 group. So the number of students will also be increasing. The first group will be having the least amount of students. The next group will be having more students, and more. So you have to maximize the number of groups that can be formed. That's our problem. I can do that. What you can directly think is that, okay, I have to first of all like form groups in which they are increasing order of the number of size of the group. So because I want to maximize the number of groups, I cannot just put like 1 people and 10 people and 20 people, because I can also still bifurcate 10 people into smaller groups that will be increasing, and that will maximize the number of groups. So the better way is just put 1 people in the first group, and 2 people, and 3 people, and 4 people in the groups like this, and you want to like maximize the number of groups. Cool. So first thing we got clear. The next thing, how we can use grades, but you will understand that using grade is irrelevant. Why? Because what you'll observe is that, let's say, if I just sort out all the people inside the grades, let's say the grades are, let's say the first example only, 10, 6, 12, 10, 6, 12, then 7, 3, 5, 7, 3, 5. Then let's say let's sort out these people in this group. So it will become like 3, 6, or 3, 5, 6, 3, 5, 6, 7, 10, 12. Now what I'll do is that I want to form a group of 1 people, then 2 people, and 3 people, and 4 people, and so on. So if I just make the group of the very smallest person, like the first group, with only the person with the very least marks, or like least grade, then if I make the next group, because it has 2 people and it is in the sorted manner, obviously this will be greater than this group because it has 2 people, so it will be more greater. And even it is like the first person is having 1 grade and the next 2 people also have 1 grade. If I just make a group of 1 size and 1 size, it will be still greater than, because it has 2 people. So what you can directly see is that I can directly make, if I just sort out all the elements in the grade, I can just like fill people in this manner, like the first people in the first group, the 2 people in the next group, the 3 people in the next group. So like filling out this grade doesn't matter to us, because we have to maximize the number of groups actually to form. So the number of groups we can form is the total size, like, because we can fill every person inside. If there are some remainder, let's say that there are people like this again, let's say it is 1 more 14 person is also there with grade 14. We doesn't care about that, because for that we have to make 1 more group of size 4, and because there are no more people, so just leave it out. We can only make 3 groups. So the number of people we want to make groups of depends upon the number of people we have, not the grade actually, because we can just put these people inside in this manner and it will be fine. So what we'll do eventually is the number of size of the people. So whatever, let's say we have the total size is, let's say 6, we want to find out the closest number of groups we can form. So the total number of groups is that we have 1 plus 2 plus 3 till n. Like if we want n groups, the total sum of this is n into n plus 1 divided by 2. So we want to just or let's say it is m. The total number of groups we form is m. So and the total number of students we have, let's say, is n. So I want such that this number m into m plus 1 divided by 2, this should be less than or equal to n. Okay, because the total number of students, let's say we have is, let's say, 1000. So how many groups I can form? I can like, can you think of that? We can do a brute force here, but because it is very large, because the grade is 10 to the power 5, it doesn't have 1 grade, but 10 to the power 5 is the length. So either you can also do this in because the length is small, what you can directly do is that you can form out groups. Okay, like you can do this in a while loop also. I think it will work, not 100% sure, but I think it will work also. But what you can directly do is that you can use binary search here, because this is a very standard binary search problem, in which what you will do is that, because whenever you see such type of sign, less than equal to sign, which means that it is also valid for less than values, because I want less than people also will satisfy this problem. Okay, because I can only also form 2 people in the group. Okay, 3 people also in the group, but 4 people I can form. So it is like whenever I see a binary search, it's like a step up function. The 1 people group is also fine, 2 people group is also fine, 3 people also fine, but 4 people it doesn't find, because from 3 people, like 4 people we don't have people, and 4 people, 5 people doesn't matter. So it's like a step up function. Whenever I find a step-up function, bind search is very helpful and require that. So what you can actually do is that you can form two pointers, let's say L and R, and just find out every n. Let's say like whether a person of like can we form 16 groups. For 16 groups, how many people are required? 16 into 17 divided by 2. That much people are required. Whether this number is less than equal to n, the number of people we have from which we can form groups. If it is good, then 16 people we can find. If it is not, we have to make less than 16 people, like 16 groups. So what is less than 16? We'll do this binary search over that. And we can do also while loop, directly while loop for every group, like let's say 1 group, 2 group, 3 group, and so on. So I think so that will also work, but you can try that out also. So we have done a binary search for a very large number from 0 till 9 group. I believe we cannot just make any group at all. And from answer, like how many people will form, this is the total size of the grades, like total number of people inside those grades array. Do a while loop less than equal to r, find out the middle using the while loop. So if this number mid is the number we are using as n, how many groups will form? So if the number of groups we form is, let's say, mid, total number of people required for number of groups is mid into mid plus 1 divided by 2. If it is less than equal to n, this is perfectly a good answer. Store that into mid, like answer is mid. No, this is not the final answer, but we will keep on updating that, but we will store that. So if you haven't understand this logic, I have a complete series on binary search. Just search it out on YouTube or on my channel itself. It's a very intensive and very highly like mixed binary search problem, so you will understand more about binary search from there as well. But this is how you can do binary search. You can just update this answer here and just go to mid plus 1, or else if it is not a valid point, we'll go mid minus 1 and answer. So it's just a very binary search. Last problem goes like this, that problem name is find closest node to given two nodes. So you're given a directed node graph in which from every node there will be at most one outgoing edge. Okay, from every node there will be at most one outgoing edge. Okay, no more than two outgoing edge, and it is a directed graph. Now what you'll have to do is that from any two nodes, what is the first node, okay, that you can reach from, like any, like if I give two any nodes, from what is the first two nodes that you can reach from the given node. And if there is no such node, then return -1, else if there exists some node, return the number of it. Now the input is given because there will be at most one edge out of every node. What they have given is that from every node, let's say index 1, 2, 3, what is the node it is connecting to? So what you can see that is the node 0 is connecting to 2, node 1 is also connecting to 2, node 2 is connecting to 3, node 3 is connected to nothing, so -1. That is how you are giving the edge array. This is the node that is, want to start from 0, the 0th node and the 1 node. What is the most common, the first very common node that it comes to is 2, answer is 2. Now for this problem, this is a very, like if you have seen this problem, this is very similar to finding out an ancestor in a tree. You have two nodes and you have to find out, let's say a common ancestor of the two nodes. It's similar to that. But what you can actually observe is, what you can directly do is that in that also we find out different paths from every node, find out the common path. Okay, like what is the common path, and just find out the very first intersection of that path. We'll do the same thing here as well. What you can do is that from this node, because it is a very like small graph, what you can actually do is from the first node, let's say from starting from this node, make the path like what. So what I'll do is that I will make what you can say, a DFS, not DFS, BFS traversal from this node as well as this node. Because in BFS traversal, it is breadth first search, in which I will traverse in, let's say, outward motion from the particular node. And in that BFS, we can actually know what is the length, or like what is the distance, the shortest distance from this particular node to every other node. I hope you get the point. So BFS help us to find out the smallest distance from the current node to all other nodes, the smallest distance. So what I'll do is I will make a BFS map, like from this node, what is the smallest distance to every other node. Okay, we will form a BFS traversal similarly from this node and this node. So we will have the distance of every node from both of these nodes. Okay, now in the end, what I'll do is I will iterate over every node, and if this node is reached by both of the nodes, the DFS map will give me that okay, 2 is reached from both of the nodes. So I will have the distance that this is reached from this node by one distance, from this node by one distance. So I just have to minimize the total node distance that we want to reach it from this particular node, and we just have to find the answer. That's our logic, okay, for this problem. And let me move on to the code part because nothing much is required to visualize it here, but I will move on to the code part if it is somewhat more required, and I will draw it out also. So what we have done here is that we have made first the adjacency map. So it is very simple and very much required to make an adjacency map for any graph problem because it will make different type of algorithm very simple to implement. So we have first created an adjacency map. What we have done is that for every edge, we'll iterate over every edge. So if it is -1, it is not connected to anything, or else if it is not -1, for this particular edge, there is a edge from this I to the node it is connected to, that is X. So from I till X, we just connected out a node. So X is the value at this point. So I to this value. So from the ith point, that is, let's say 0th index, like 0th edge, it connected to the value at this edge I. So we just match the. Now we have created two distance matrix that will store out the smallest distance from the current node to all the other nodes because there are n nodes. So created this, as well as visited because we don't have to traverse the same node again and again. So it is a visited array. It is very standard to do how like the BFS work. And then we have started the BFS from both node 1 and node 2 and like send their distances and their visited matrix because it is like two different type of DF, like the same algorithm but two times from two different nodes. Okay, now how this BFS works is very BFS standard problem. We'll take the starting, let's say, node that is B. What I'll do for BFS, we have to make a queue, created a queue, push back this particular node inside this and initialize the value by 1, that is, it is 1 distance. The distance is 0 because we are on the current node, so the distance is 0, but visited equal to 1 because now we have visited this particular node. What I'll do is I will keep on iterating over this queue until it's not empty, pop out the first element from the queue, and then iterate over all the adjacent elements connected to this queue. It is only at most 1, so just push that inside this. If it is not visited, if it is already visited, we will just continue. If that node is not visited, push that inside the queue, mark it as 1, and then the distance of that node that we have that is adjacent to it will be the distance of the parent node to the current, like the node we are moving to. So what we are trying to do here is that this is a very if you have not understand let's say BFS, go watch out a video on BFS, it will become more clear to you. But let's say we have nodes like this. Okay, so what I'll do is from this node, let's say the distance is 0 because it is the very first node. We want to start iterating from this node, so it is 0. Then we'll move to all the adjacent nodes. So the only adjacent node is here is this. So we'll move to the adjacent node, and the distance from this node, because we want to find out the distance from this node to every other node, the distance from this node is this distance plus 1 because we have only moved one step ahead, so it is 1. So which means that this node from this node is 1 distance away. Then when I move to this node, I will take this distance plus 1, so it is 2, which means that this node is 2 distance away from this node because we are only finding out distance from this node only. So we will keep on like taking this distance, and everywhere we move 1, take the parent node and add distance 1, so that we know that we have moved 1 distance away, and keep on appending that. So we will have that this is 1 distance away, 2 distance away, 3 distance away, and so on. So we have all of the nodes. Similarly, we will take one more node and just find out the distance from there also, and just create the make the BFS map of the distances. So this is how you will do a BFS, generally BFS. So BFS will tell you the smallest distance from every node, the starting node to all the other nodes. After that, what we'll do, you have to find out the answer and the node. Okay, answer is the smallest distance and the node is the actual node we want to print out. That is the common. So iterate over every node. Okay, if either one is -1, which means that I cannot reach that node. Okay, if that node cannot be reached from any one of the two nodes, the answer is -1 only because that node should be reached from both the nodes. Okay, if it is not reached from any one of the nodes also, it is -1. Continue out. Now what I'll do is that if it is reached from both the nodes, what I'll do is that I will have to first find out the maximum distance. So let's say from one node, this is one of the nodes, the second node. So one of the nodes, it is reached in, let's say, 2 distance apart, and this is 5 distance apart. We will take the maximum one because it is 5 distance apart. So the problem statement says that what you have to do is that you have to choose the maximum between the distance from node 1 to the node and the node to the node. So both of the distance from node to node 1 and node 2, you have to maximize, but for that maximum value, you have to minimize this. Okay, so what I'll do is that find out maximum value, and if the maximum value is -1, update the answer. If it is greater than if it is not -1 and the answer we got is smaller, because we want to minimize that value. If it is still minimum, update the answer. So we are just finding out the updated value of node of I and then print it. So that's the overall logic. You can go over the code part once again so that it will become more clear to you. But that's the overall logic for the first 3 problems from the latest Leetcode weekly contest unit 4. Stay tuned for the 4th problem as well. Thank you for watching the video to the end. I will see you in the next one, the Leetcoding, and bye.